Okay, we want to look at some mechanisms of what we call natural climate change. And you have to understand that some climate change is very cyclical, as we've seen in these, as the book explains, and we've seen in these previous slides, where you go through these natural cycles of warming and cooling. And that's what we'll look at here. This is different than what we call anthropogenic change, where the climate change is related to actions taken by humans. So these are the natural ones. We've mentioned volcanoes, and that's of course one of them. Another one would be sunspots, and then the wobbling of the Earth on its axis, for example, is another one. So some people, some scientists have pointed to these times when there were fewer sunspots, and that was the occasion for some changes in the climate. But again, that's not responsible for the current warming trends because sunspot activity has been fairly normal. Then there's the Earth's orbital cycles, what we call the Milankovitch cycles, where the orbit will change very slightly over about every 100,000 years. And we get these also get these axis wobbles, what we call precession, in 26,000 year cycle. And so what this causes is the tilt of the axis to vary a little bit from 21.5 degrees to about 24.5 degrees. And that's in about a 41,000 year cycle. And this would, put more insulation into both hemispheres and increase warming there. But all these take into account the natural aspects of climate change, meaning that these are things that happen naturally over these cyclical periods of time, 100,000 years, 26,000 years, or 41,000 years. So this is here's the three Earth-Sun relationship factors of the Milankovitch cycles. So it varies during this 100,000 year cycle, our elliptical orbit varies. And then at the same time, the axis can wobble and we can also tilt. And so based on that, you can get these periods of glaciation. So due to the wobble, the tilt, the ellipticality of the orbit, and you get these stages of glaciation that match up pretty closely. So wherever you get more of these, we tend to get more glacier activity. And again, that's natural cause. And this just gives you some idea of the extent of the glaciation back in the Pleistocene era. Down all through Canada and then into the northern United States, covered up the Great Lakes, of course, and then into most of northern Europe. And notice in Europe, here's the ice, but sea levels were different. So 16,000 years ago, all this was land. So United Kingdom, Ireland, they were actually connected to the European mainland. But then sea levels have gone decreased, and here's the land today. It's just, sea levels have gone up. My mistake. Excuse me. Sea levels have gone up because the glaciers melted, and the land in this green, darker green, disappeared, and we get the Earth's surface the way we know it today. So continental position of topography also plays a role in this. So, we'll study continental drift in chapter 8, but about 220 million years ago, most of the land masses were connected, and then because the tectonic plates moved, the continents have drifted, and that puts them in different places on the Earth's surface, and therefore they'll get different amounts of insulation and so forth. So they might have been exposed to colder weather at some point in time, but as they moved, they would get exposed to either warmer or colder temperatures. Here's another way to look at this. So here's 20 million years ago. You can see that this was where Panama is today. The water flowed, the Atlantic and the Pacific were connected, and so the warmer currents flowed from the Atlantic to the Pacific, and the North Atlantic was cool. Now today, as that land bridge is closed down, and so the warm currents flow toward the North Atlantic up this way instead of going over here. Now they go up this way. So notice the difference. This was cooler, and now it's a little warmer. And again, that creates these different climatic conditions for different periods of time. Then there's our atmospheric gases and aerosols. And again, most of this is due to massive volcanic eruptions. And there's, again, a couple videos in your weekly module. I'm looking over at them. So one on supervolcanoes and one just general one on volcanoes and climate. So you might want to watch those and get some idea of the effect that volcanoes can have on the climates. Because again, these aerosols and particulates, they can block out the sun, for example, and the temperature would drop. Okay, so we'll end here and do what we call climate feedbacks on the next part.